Hello there, this is an Algebra 2 video, Chapter 6, Section 3, and today we are discussing square root functions and inequalities. It's important for us to discuss these functions because we just learned in our previous lesson that about inverses, and of course square roots are inverses of squaring functions. So, basically it's the inverse of the parabola. So, what you see on the board right now is basically the properties, aka characteristics of the parent graph square root function. This is what a square root function looks like. The function itself, f of x equals square root of x. You'll notice that it only has positive square root of x. If you had plus or minus the square root of x, the negative square root of x, as we will discuss later, is the bottom portion of the sideways parabola. And so you know what a normal parabola looks like. It's kind of got the little U shape going like this direction. This is like a parabola on its side, but we're only dealing with half of that parabola, the positive half. And so that's the square root function. And the domain of the function, which basically refers to all the x values that are able to go into the function, we already know from before that you can't take the square root of a negative number. So for that reason, the domain is all x values such that x's are greater than or equal to 0. So you'll notice that the graph starts right at the origin and then goes on to the positive side, does not go to the negative realm as far as the x-axis is concerned. And then your range is the possible y values, and you can also see from the graph that the graph does not go below the x-axis. It starts kind of here at the 0 and then moves on up. So for that reason, we have the range, the y values, such that y's are greater than or equal to 0. Intercepts, where it crosses the x or y axis, and you can see in this case that it crosses the x and y axis at the same time at the point 0, 0. So right here, smack in the middle, is our x and y intercept. Okay, not defined. Values for which the function is not defined. We mentioned that earlier when we were talking about domain. The function is not defined when x is negative. X cannot be less than 0. If you have a number in the place of x that's negative, it's not going to give you a value. It will not be defined there. And of course, we want to talk about end behavior. We know that x approaches 0 when you're approaching 0 on the x-axis. So as I'm on the x-axis and I'm kind of moving along, going towards 0, the function itself is also going towards 0. And when I'm going away from 0 or to positive infinity, the function is also going to positive infinity in the y direction. So that's basically the basics of square root functions that you need to know what the function looks like because we're going to be graphing it today. And so we'll start here with example 1. Says, identify the domain and range of f of x equals x plus 4, the square root of x plus 4. So what we need to do is, like I said before, as far as domain is concerned, we have issues with domain whenever the bottom of the radical is not greater than or equal to 0. So for example, here we go back to the screen, domain, we want the x, which is the part that's underneath the house, which we call the radicand. We want this value to be greater than or equal to 0. But in our example, we don't have x, we have x plus 4. But nonetheless, we want that entire expression, x plus 4, to be greater than or equal to 0. We want it to be positive. So how do we figure out when it will be positive? Algebraically, it's very simple. You just set up an inequality and solve it. So our domain will be all x's such that x's are greater than or equal to negative 4. As long as the x values are greater than or equal to negative 4, we're going to be okay with our function. Because if you plug in a negative 4, you'll get negative 4 plus 4 is 0, and the square root of 0 is 0, that's okay. And then if you plug in a number that's bigger than negative 4, you'll be fine. If you plug in a number that's smaller than negative 4, like negative 3, then that's where you'll get, like negative 5. Negative 5 plus 4 is negative 1, and the square root of negative 1 is undefined. So there's your domain. And then to find your range, you'll also notice that as far as the range is concerned, it starts right here at the very end of the graph. And so this is basically where the domain begins. So what we want to do is find the lower element. So basically what I want to show you is that on the x-axis, the domain starts here at this low end, and on the high end it goes on forever. So this is where it starts. So what you want to do is, now that we've verified that our domain is not going to start at 0, because 0 is not greater than or equal to negative 4. Our domain is going to start at negative 4. So to find the range, it's real simple. You just plug in -4 into the actual function. What is f of -4? When I evaluate what f of -4 is, that'll tell me what the range is going to be. So f of -4 is going to equal the square root of 0, which is 0. So in this case, our range is going to be the y values such that y's are greater than or equal to 0. In other words, despite the fact that we aren't starting at 0, 0, the range is still going to be greater than or equal to 0. And I probably should have put this little thing in there, not over here. Okay? So now you can try do it yourself number 1, and we will move on to transformations. Transformations are like parabolas in any other function. You can shift graphs left, right, up, down. And so in a very similar fashion, a lot of the same letters here, they're going to do a lot of the same, they're going to have the same kind of effect they did in the parabola situation. But again, I just want to reiterate it for you, and if you had forgotten or you don't want to go back and look at your notes, you can rewrite it into your notebook again. The H represents the horizontal transformation. So basically, if you have a plus H here, then that means you're going to move the graph H units to the left. If you have a minus H, you're going to move it H units to the right. In the case of the K, and please notice that when you see a minus H, it actually goes to the right, which is the positive side. And when you have a positive H, it moves to the left, which is the negative side. That always happens with the H, okay? But in the K's case, a positive K means positive up, and a negative K means negative down. Very straightforward with the K's. And then you have A. A is the number in front of the square root. So the A is responsible for the orientation and the shape of the graph. In other words, you can have a square root function that looks like this, or it can be like a fatter one or a skinnier one. It can be upside down. So all of those things are determined by the value of A, just like it was with the parabolas. So basically what we have here is 5 different things that are happening. If the A value is negative, then you're going to have an x-axis reflection. That's basically like positive x squared versus negative x squared. It flips it over on the x-axis. So in the case of A being negative, then your square root function, instead of being like this, is going to flip over and have a negative or x-axis reflection. Now, if the absolute value of A, so we're not talking about it being positive or negative anymore, we're talking about the value. Like, what if you have 2 root x versus 1/2 root x? Okay, so 2 root x would be a situation where the A value is greater than 1. So in that case, you're going to stretch the square root function. So it's going to be a lot, when you stretch it, it's going to get really skinny. It's going to be closer to the x-axis, so to speak. And then the compression over here is when A is like 1/2 root x. That's when it's going to get a lot wider. It's going to go like that. Okay, so it's just basically going to affect how fat or skinny or how stretched or compressed it appears to be. And then, of course, over here, this is important. This will help you with your range. If A is greater than 0, meaning it's going to be looking like this, then the range is going to be y greater than or equal to k. So whatever your k value is, it's going to be y greater than or equal to k. So you're going to start here, then move up. But in the case where A is negative, your graph's going to look like this. And so therefore your range, instead of going up, is going to start at k and go down. So you'll see that it says the range is y less than or equal to k in that case. Alrighty, so keep that in mind as you transform graphs, because we're going to do that now. So we have here y equals the square root of x minus 2 plus 5. They want us to graph each function, state the domain and range. So for domain, I'm just going to take the x minus 2 and greater than or equal to 0. So notice that I'm not adding the plus 5 part. As far as the domain is concerned, all that matters is what's underneath the little house. So I'm only making x minus 2 greater than or equal to 0. And when I do that, I get x greater than or equal to 2, and that's my domain. All x's such that x is greater than or equal to 2, And then for my range, because based on what we saw here earlier, if the a is greater than 0, then my range is going to be y greater than or equal to k. All right, so my range is going to be y such that y is greater than or equal to, and in this case, you'll notice that my a value is a positive 1, and because it's positive, my range is going to be y greater than or equal to k, and my k is a 5. So there's my range. And now I'm going to graph the function, and basically you graph the function the same way that you would graph the parent graph. And I didn't really go over that very much, but I will tell you right here that what I did over here is I just kind of made a really quick t-table, and I said to myself, if x is 0, then the square root of 0 is 0. I can't get negative numbers, but if x is 1, then the square root of 1 is 1. And then I went all the way to 4, because I know that the square root of 4 is 2. And that's kind of how I graph those. So those are my main points that I use. And so I'm going to use the same points to graph this little guy. But I'm not going to start at 0, 0, because the minus 2 tells me to shift my graph 2 units to the right. And the plus 5 tells me to shift it 5 units up. But because so I'm going to start here. So instead of starting at 0, 0, I'm going to start 2 units to the right and 5 units up. But aside from that, because there's no a value and there's no negative, my square root function is not going to be upside down. It's not going to be stretched or compressed. So I'm going to pretend that this is the origin. So if this is the origin, then the point that I was looking for, this is my 0, 0. So then my 1, 1 is going to end up being 1, 1 here. And then my 4, 2 is going to be, that's 1, 2, 3, 4, 2 is going to be like up here somewhere. And my graph will look like this. Alrighty, so that's how I'm going to graph that little guy. And in a similar fashion, we're going to come over here and graph this guy as well. 1, 2, 3, 4, 5, 6, 7, okay? Now, if you don't like that method, you can always make your own, t-table, but really the point is to use the parent graph as much as you can when you're graphing. So in this case, again, we want to start with the domain and range. So we've got x plus 3 greater than or equal to 0. Subtract 3 from both sides. So x is greater than or equal to negative 3. So in this case, our domain is all x's such that x is greater than or equal to negative 3. But this time for our range, because this value is a negative a value, it means that our range is going to be y less than or equal to k. So less than or equal to negative 1 in that case, unlike the previous case, okay? So what's going to happen here is the x plus 3 means I'm going to shift the graph 3 units to the negative side. So we're going to be 1, 2, here's negative 3, and then 1 unit down. So I'll undo the negative 3 because now it's in my way. So here's negative 3, and then negative 1 is right about there. So we're going to start the graph here. But instead of it going like this, it's going to go down like this. All right? So what's going to happen in this case is that normally this is now my origin. Remember what I said earlier? This is now my origin. So when I go 1, 1, instead of going 1, 1, I'm going to go 1 down 1 because of the fact that it's upside down. And then I'm not even going to go down 1, I'm going to go down 2 because this is times 2. So I'm going to go, this would be going down 1 over 1. So I want to go down 2 here. So there's my point, and my square root function is going to look like that. So in other words, just so you can see that I'm telling you, this will still check out even if you pick a different, like if you pick a t-table to do it with. Let's say that you didn't want to do it that way, it's too confusing or whatever, and you want to pick, this is negative 3, so this is negative 2. What is the value of the function when x is negative 2? Negative 2 plus 3 is 1. the square root of 1 is 1. 1 times negative 2 is negative 2. And negative 2 minus 1 is negative 3. And what you'll see here is that at negative 2, this is negative 3. So you see it still works. So if you want to use a t-table to find your values, that's fine. But you can also do it the way that I did. So now you can try do yourself number 2. And then we're going to go on to this example here. And then we have one more example. There's only 4 examples, so hang in there if you're starting to get tired. All right, it says, again, we want to refer back to the beginning of the section. There's an application problem in your book that kind of just explains the whole scenario. But in a nutshell, it says the pitch or frequency measured in hertz of a certain string can be modeled by this function, which clearly has a square root thing going on here, where T is tension in kilograms, and it wants us to graph the function for tension in the domain, and so they're telling us what our domain is. See, normally the domain would start at 0 and then go on forever, but for the purpose of this problem, they want us to only go from 0 to 10, so my graph only goes from 0 to 10, and they want us to graph it. After we graph it, they want us to find out how much tension is needed for a pitch of over 200 hertz. So remember that the T is the tension, so they want us to solve this guy for T. So they're going to tell us what the pitch is, which is the F of T. So we're basically going to plug in 200 equals 1 over 1.28 square root of T over this crazy number 1, 2, 3, 4 zeros, 708. Okay, and we're going to solve that equation. But first, we want to graph this function. So, I'm going to use my calculator to help me get values, to generate values on my graph. I'm going to make a t-table basically. All right, but I'm not going to write the t-table on the board because I don't have any space. And so what I'm going to do is I'm going to plug, excusez-moi, I'm going to plug in the 1 divided by 1.28. I'm putting that in parentheses. I want to make sure that if you're doing this with me, you can, I put that in parentheses, and then I'm times that by the square root, also in parentheses, my variable divided by 0.12340,708. Close that, and then graph it. And you'll notice that I already have my scale here. I need to change my scale in my calculator as well to go from 0 to 10 and from 0 to 320, and we're going by 40s. All right, so I'm going to plug in 0, looking for my value function on the calculator. So we get 0, 0, and then we're going to plug in 1. At 1, it's about 92. So, but when we get to 2, we're going to be at roughly 130. So that's 40, 80, 120. So maybe about right here. 4 is going to be 185. So when it's 4, it's going to be 185, which is right about there. At 6, we're going to get 227. So 227 is going to be maybe 2, 4, 6. So probably right about here. And then let's just go all the way to 10. We'll be almost 300, 293. At 10, we'll be at 293, so something like that. So we get our graph, and it kind of looks something like that. My points aren't exactly on there. These first few were kind of better than the last ones, but you get the idea. That's what the graph looks like. So they wanted us to graph it for our domain, and you can use your calculator to help you. And then for this part, we want to solve this equation. So the first thing I want to do is to multiply by 1.28 on both sides to get rid of this little fraction here. And so 200 times 1.28 is 256 equals the square root of all that. To get rid of the square root, we are now going to square both sides. So now I'm going to get t over 0.0000708, and then the 256 squared to the other side. To get rid of the 0.0000708, we're going to multiply by 0.0000, like that on both sides. Okay, and then those will cancel, and then finally we'll know what t is. So t is going to equal 256 squared, which is 65536, and then times that by 0.0000708, and we get approximately 4.64. It's 4.6399488. So roughly, we have 4.5 kilograms, or 4.6 in this case, 4.6 kilograms of tension in our string if you have a pitch over 200 hertz. Alrighty, so that's how you do that. And so you can do this do-it-yourself question. And then we will go to our last example. And our last example is involving inequalities. So we're still graphing square root functions, but this time we have an inequality. So just remember that as far as the inequality is concerned, just remember that a less than means you have to have a dashed boundary curve as opposed to a solid boundary curve. And if it's less than, you shade below, greater than, you shade above. But of course, there's always a way to get around the shading thing. If you don't know what's above or below, you can actually use a test point to do that. And we'll be doing that when I do this example. But for the rest of it, the x minus 4 minus 6 tells us how to shift the graph. The x minus 4 is going to tell me that I need to shift my graph 4 units to the positive direction. So here's 1, 2, 3, 4, right about here. And the minus 6, but then you need to shift it down 6 units. So 1, 2, 3, 4, 5, 6 is here. And 1, 2, 3, 4 is there. So I think it's right about here. Okay? And this now basically becomes my origin. It doesn't ask me to state domain and range, but this basically now becomes my origin. There's no negative in front of the square root function, so I'm not going to make it upside down or anything like that, but I'm going to go over 1, up 1, and over to the 4. So 1, 2, 3, 4, 5, 6, 7, 8, and then that'll be right about here. Oops. We want to make that a dashed boundary because this is a less than, not a greater than. So basically what I'm doing here is that if this is my origin, 1, 2, 3, 4, I feel like my thing is shifted over. It should be over here. But if this is my origin, I'm going to go 1 unit over, which is going to be the 5, and 1 unit up, which is my 1, 1. And then I need to go 3 more over, because that's going to be the 4. And remember, when the square root of 4 is 2, and I'm going to go up 2. So that's kind of what I was trying to do there. So you can kind of see that there's my graph. Again, if you want to use a t-table, you're welcome to do that. But now we need to do some shading. And to do some shading, you can pick a test point. And so what I'm going to do is I'm going to test the origin. I always like to test the origin. You don't have to test the origin. It can be any point that's not inside of the graph. But basically, we don't want to shade anything beyond where the function starts. So when we shade, we're going to shade either here on, below the graph, or above the graph. But we don't want to shade to the left of the graph because that's the part that's undefined, remember, as far as the domain is concerned. But we can test a point that is inside. So for example, I can test 1, 2, 3, 4, 5, 6, 7, and maybe -6. Okay, so the 0.7 -6 is right here. And I just want to test it to see if it gives me a true or false statement. If it gives me a true statement, then I'm going to shade that area. If it gives me a false statement, I'm going to shade the other side of that area. So I'm going to put in the y's place -6 less than square root 7 minus 4 minus 6. Well, the square root of 7 minus 4 is 3. So what I need to figure out is what is the square root of 3 minus 6. So the square root of 3 is 1.73 something. Minus 6, I get -4.26. So is -6 smaller than -4.26? Yes, it is. Because when you're in the negative world, the bigger the negative, the smaller the number is. So that is totally a true statement. So it means that I'm going to shade this area. But remember that you want to stay right with that line there. You do not want to go past this line when you are shading. All right, and also I should add that our endpoint should not be closed but open. So this point here at the very end, oh goodness, let's get the right marker here, should be open, okay? But again, do not go beyond that boundary and stay under the curve, and then you'll be fine. So that is how you graph an inequality that has a square root in it. And so now you will try these two, and once you have completed this example, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.